Hi there, I'm Professor Robert Kumar, and I wanted to create a small tutorial on one of the data structure that students would learn during intermediate programming is what we call a stack, right? A stack is one of those items that's been out there for many, many years, used in various scenarios, depending on what the situation is. So what I'm going to do is going to share my screen, all right? Hopefully everybody's seeing that. And I'm also going to make sure that the recording is on. So, the stack is basically, it's pretty cool, right? And visually, right, a stack normally looks like that. It's like you want to call it a bucket, right? Bucket kind of thing, where you put items in, right? Items in, and then you put items out. The method stack uses in operating items coming in and going out is last in, first out, right? Which means if I put in a number, if I put in an a number, let's say number three is here, number 5 goes here, number 6, and then I put number 7, right? The only item I can take out is really number 7. So if number 8 comes in, right, number 8 will go here. Only item I can take out is number 8. So that is the whole idea of last in and first out. Compared to a queue, right? If you have a queue normally looks like that in visually, right? Items would come in this way, but items would go out that way. When I say items, I'm talking about elements that I stored in the queue or the stack. So that is how a stack is different from a queue. This is all right. The cool thing about a stack is that it has only 5 or 6 methods. That's it, right? There is, I mean, it's the coolest thing ever, right? And I'm not sure who created this, but it's a great idea. So in a stack, okay, normally you have an empty one, of course. If you want to put anything in it, right? Put anything in it, you have to use the push method, right? Dot push method, and you supply what values are you putting in? Let's just say I'm putting in number 12, right? Number 12. That will, and let's just assume that the name of this stack is st. So I'm going to say st dot push, right? st dot push. That will basically put 12 in here, and 12 will end up in my stack. If I do another one, st dot push, and let's say I put 24 here, that means now 24 will go in as well, and 24 will end up here, all right? So as long as I'm putting data in using the dot push method, it will keep on adding items to it. In order for me to remove item, right, the only thing that's available for me to use is st dot pop. Right, that means it will take out 24 from here, 24, right? It will take out the item that is currently on the top because we use the last in, first out mechanism, right? So that is how these two are the only methods you can add items in the quick stack, and this is the only method you can take out items in the stack. Other methods is available for a stack is what we call a peek. Peek is pretty cool, right? Peek. And once I write some code, I will show you peek. Peek basically means get me what's on the top. So this will give me 24, right? Give me what's on the top. Peek means I want to peek. Take a look at what's on the top. That will give me a peek. The other method that we use here is called a empty, right? Empty is when we code. I will show you what empty is, and empty basically tells you whether any items is in the stack or not, right? So that is that. And then also the other I'll also show that is a search method that allows you to search items in the stack. So let's just understand how the push, right? Peek and I'm sorry, no, push, right? Push. Actually, peek is what I'm looking for. Push. Well, not yet. I want to take this out, right? Okay, I have. Let's just say I have a stack here, right? And then I want to push a number, 55, right? That puts 55 right here, right? And then I want to push another number. Let's put 65, right? That will put 65 right here. Okay, then also I want to push in another number, and let's just put I want 75, right? 3 numbers, so that will put 75 right here. Okay, now Now, if I do a top, okay, tell me what's on the top. That will give me a 75. All right. Now, what I'm going to do is that I'm going to do a pop. Pop means take the top out, right? Take the top out, and that will take out 75 right here. Take out 75. Now that I do, and then I'm sorry, this is not a top. This is a peak. I don't know where I got a top from, but this is a peak. Now, if I do a peak, right, that will give me that value. So that is pretty cool. That is how the stack works, right? Other two methods I can use here is empty. Empty will tell me whether it's empty or not, right? But anyways, in a nutshell, that is what it is. So to write some code to see how this is implemented, right, I want to go ahead and open up, right, I have my C++ compiler here open, but I'm not going to use this. I'm going to change this to a Java, Java compiler. So, I'm going to take out this code because I need some space, right? I need some space. Okay, in order to get, a stack implemented, one of the first things you need in Java is you need to import java.util.stack. You need to import that library, which has the code that you will use in order to implement your stack data type. So taking this out, I don't need that, and I'm going to declare stack, right, of int type, right? So how is this done? I don't like it when it's well, it is nice that sometimes your coding editor tries to complete coding for you, but sometimes it could be annoying. All right, how do we go about implementing a stack? Basically, you declare a stack and you say here, right, integer data type, right, and then you put so what name should I put here? This would be, let's just put lowercase stack, right, lowercase stack, and I can say here is equals to new stack. Remember, everything in Java, in order for you to use, you have to use the new keyword. Pretty much everything, right? Well, not everything, but most, most data structures that are not primitive type, you have to use a new. So now that I have my stack already, right? What I'm going to do is that I'm going to, first thing first, I want to check if there's anything on my stack. So I'm going to do a sysout. Hopefully that will not work for me, but system.out, out.println, right? And here I'm going to put is empty, right? And then plus, you can use the method called stack empty, lowercase, right? Now close that with that semicolon here and run my code, and hopefully that gives me a true. True means there's nothing in it. Okay, so that's net. That's you check if stack empty. Right now, the next method also is now we want to add some items to the stack, right? And the way we will do that is by using the code that will call so this is to add items to the stack. All right. How do we do that, right? Stack dot push, because we're adding items on the top, right? So push, and let me just create some numbers here really fast. 89 stack dot push again, and this will, I'm going to put 45 here, right? So just remember that the diagram that I had, right? The diagram that I have so far. So I have my stack right here, and I'm putting, I think I put 89. So 89 would go here, right? 89 and then 45, right? Because this was pushed first and this was second. So, anything that goes in first is right at the bottom. All right? So that is that. And then stack dot push, let's put 88 in it as well, right? So now my stack should have two things. My stack should not be empty. So I can basically take this code, all right, and run it again to see if what it tells me, right? If it tells me that if it's empty or not, and that should tell me that it is not empty. All right, you see that? It says it's empty, it's false, because I have items in my stack. All right. Okay. The other code that's really important dealing with the stack is the peak. peak tells me what item, what item or what value, what item is on the top, or the last item added to the stack, correct? So now I can simply say, I'm going to copy this code because then I don't have to type it over and over again. So it's, here I'm going to say top, right, top, and that would be plus, that'd be stack.peak, double E, peak, close that up, semicolon, run this line of code. Let's just see what happens. So according to what we have done, right, right, that's the first item pushed onto the stack. That's the second. There's the third, right? The last item put on the stack was 88. So 88 is on the top. That's why when I do a peak, see, when I do a peak, it gives me 88. All right. Now that is good. What I'm going to do now is I'm going to, the other thing that I'm going to do is I'm going to show you how to use a pop. The only way, like I said, to add items to a stack is by using the push method, and the only way to take it out is by using the pop method, right? Now, when we do a pop on something like this, if I do a pop here, right, 45 would go out. That means it will take away 45. 45 will disappear, and then we will end up with no 45 here, right? That's a pop. All right, that's a pop. So just keep that in mind. Okay, so now I'm going to do a stack.pop, right? And then also I want to do a peak at the same time. I want to do a peak at the same time. So I'm going to copy this code and I'm going to put right here. I want to see because remember, according to what we have discussed, right, the item that should be on the top of the stack is 88, right? And according to, when I do a pop, that means 88 should be gone, right? 88 should be gone. I should see 45 now, right? So I'm going to run this code and see if I do see 45, which is right here at the bottom. Okay, looking good so far. So now that is that, right? The other piece of code that also you use when dealing with the stack is the size, right? How many elements is in the stack? So now, and that is fairly easy too, right? I'm going to paste that line of code that I had from before, stack dot size, right? So this will give me the size or number of elements, right? Number of elements in the in my stack. So sometimes I'm using number of items in the stack or number of elements is the same thing. Okay, I'm referring to the same thing. All right, so running that should give me a number of elements is 2, right? Number of elements is 2, right? So now another code that is very common in stack is when you want to find something, right? You want to find and see where is it. So basically, I'm going to do something. I'm going to add a couple more items here. So stack.push. Let's put 10, right? And then stack.push. Let's put another maybe 20. All right, and then another one. Push. So now I have a few items. Okay. Now this code that I'm writing below, this will allow you to search for for item in the stack, right? This will allow you to search for item in the stack. So the way you can do that is Java provides this other method, which is really cool. Is you can say, in this case, I'm just using my normal. Actually, that code is wrong. I pasted it and cleaned it up. This comment is wrong too, right? And the way you're going to do that is simply you say stack.search, right? Search, and I'm looking for 30, which we know it's there, right? We know, actually, let's look for 20, right? Let's put 20. So let's see what, search for 20. Let's see what this produces, okay? All right, it gives me 2, right? It gives me 2. That means 20 is 20. I mean, the value 20 is sitting at location 2, right? Location 2. Remember, when you're dealing with a stack, there is no zero index. There is, you just count from one to whatever it is. So now that I've got that, also I want to do is I want to go ahead and you know, I want to try something different, right? Because I know that this number 200 is not there, right? And I want to see what output what response does the Java give me when I'm looking for a number that is not in my stack. Right, look at that, and it gives me a -1. So, right, it will give a -1 if not found, right? Not found, and it will give you the location if found, correct? So that is the whole idea of a stack. You know, the beauty of this thing is that there is only a few methods, right? 5 or 6 of them, not too many, right? We have you have the push, which is 1, empty is 2, peek is 3, right? Size is 4, and search is 5. So five methods that you can use to implement stack. So normally, every time that I do a lecture, I ask my student to do an assignment, in-class assignment, and submit it to me, right? Because I want to see. So I want you to do this. I want you to create a stack, right, of list of maybe friends, right? Friends, and then I want you to add a few friends to the queue. Actually, not a list. Why did I say a list? A stack, right? Stack, and then also I want you to remove 2 of your friends, right? And then also, get the size, and then also I want you to tell me, right? Show what's on the top or the last item, the last friend that was added, and then also line 6 is I want you to show me if the stack is empty, right? So do those and submit the code as your in-class activity. I want to see if you've been able to follow the example that I've produced on the left that we work together on, and see if you can follow this example and do this exercise, right? Let me know. Okay, let me know if you have any questions. And anyways, good luck, and I'm here to help you. Thank you.